Hello class, welcome back to Statistics and Mathematics YouTube channel. Today we are starting our class on Poisson distributions, and we are saying that Poisson distributions is a probability distribution that describes the likelihood of a given number of events occurring within a fixed interval of space, assuming that events happen independently and at a constant average rate. So for example, if let's say we want to see within 30 minute period how many students were able to enter the class within 30 minutes period, right? This is in an interval rate, right? We use Poisson distribution to check that, and then this event happen independently. So in our previous video we explained that for independent events happening independent is telling us that the occurrence of one event does not affect the occurrence of the other, and these are all at a constant average rate, right? So for Poisson distribution we have PMFs. For Poisson distribution, that's the probability mass function for Poisson distribution. The probability mass function for Poisson distribution is equal to e raised to the power negative lambda times lambda e raised to the power negative lambda, right, times lambda raised to the power x divided by x factorial, x factorial, right? So this is what the PMF for Poisson distribution. So the x that you can see there is event, right? It's just the event, and then the lambda that you can see there is represent the average number of occurrence, right? The average number, the mean number that was in that interval, right? And then the next one that I want you guys to also appreciate is the mean and variance for Poisson distributions, right? The mean for Poisson distribution is the lambda, and the variance too is lambda. So Poisson distribution is the only distribution that you can get the mean and the variances to be to be equal, right? So at the end of the day, if they ask you to give them the variance for Poisson distribution, the same as the mean for the Poisson distribution. So let's go back and then solve some examples on Poisson distributions, right? So this will be our first example on Poisson distribution. Example 1, it said if there are 200 typographical errors randomly distributed in 500 pages manuscript, find the probability that a page contains exactly 2 errors, right? So at the end of the day, we are saying that we are having 200 typographical errors out of out of 500 pages, right? And then we are asked to find exactly probability of a page containing exactly 3 errors, right? So here our x is giving us 3, right? Yes, our x is giving us 3 inside the question, and then our mean, right, as you can see here, will be lambda, right? Here the mean was not given, so we have to find it ourselves, right? So our lambda will be equal to the 200, as you can see here, divided by the 500 pages, right? So here will be 200 divided by 500. That will be for our lambda, and then here will be our x, right? Our x will be equal to 3, as you can see here, right? So once we have our x and then we have our lambda, we calculating or find the probability that a given page contains exactly 3 errors will be very simple for us, right? So here we have our lambda and then our x, right? So when we come here, we are just going to substitute in this parameters that you see here into our PMF for the Poisson, right? So the PMF for the Poisson is probability of x is equal to e raised to the power negative lambda times lambda raised to the power x divided by x factorial, right? So at the end of the day, we are just going to substitute in the lambda as you can see here, right? The lambda as you can see here, and the x as you can see here into this function, right? So according to the slides, you could see that it was reduced, right? This one, the zeros will cancel as it will left with 2 divided by 5, and then the final answer for the lambda will be 0.4, right? And our x will also remain 3, right? So you are just going to substitute it into this, right? So here with e raised to the power negative 0.4, since lambda is 0.4, e raised to the power negative 0.4 times lambda, right? So lambda here is what? 0.4, right? Raised to the power 3. The 3 is what? The x. As you can see here, lambda raised to the power x. So the 3 is the x divided by the x factorial. That's the 3 factorial, right? So once you have this one, and then you point it on the calculator, you are surely going to get this answer, right? So this is how we can solve that question, right? So sometimes the mean will not be given to you. You have to find the mean, right? But in most questions, the mean is always going to be given to you, right? So let's tackle the question 2, right? So the question 2 is telling us to, he said a sale, right? A sale firm receives, right, on average 3 sales per hour, right? So here our mean is given to us. That's the average, 3 sales per hour on a toll-free number. For any given hour, find the probability that it will receive the following, right? At most 3 sales. So you see, in some of our previous videos, I explained the at most, the at least, and the rest, right? And I told you guys that for at most is more or less less than or equal to, right? So less than or equal to. So for this one, we are going to start from 0 to what? 3, right? We are going to calculate the probabilities from what? 0s to what? 3. So here it will be something like probability that our x is less than or equal to what? 3. So here will be equal to probability that our x is equal to 0 plus probability that our x is equal to 1 plus probability that our x is equal to 2 plus the probability that our x is equal to what? 3, right? So that will be for the at most. And for the at least, I told you guys that it's greater than or equal to, right? The at least is greater than or equal to, like greater than or equal to, right, a certain number, right? So here our number is 3, right? So here will be probability that our x is greater than or equal to what? 3, right? So in other sense, since the n, you don't have any limit for the n, you are going to run this one from 3, 5, 6 up to infinity, right? So the best way for us is to do it in its opposite way, right? So here if you do it like this one, you get p greater than or equal to 3 to be 1 minus p x less than or equal to what? 2. So this one, once you use this formula to, you'll be able to get your answer here. And then 5 or more, right? The 5 or more, 2 is more or less is also like probably that our x is greater than or equal to what? 5, right? So it's more or less 1 minus probability that x is less than or equal to what? 4. So here this one is like at least 5. The 5 or more is the same as at least 5, right? You know that the 5 itself is what? Included. So once you know this one, you solving it will be very, very, very what? Simple for you, right? And then at the end of the day, right now we know from our question that our lambda is what? Equal to what? 3, right? And then we have our x's here. So we solving this question is very, very simple. But for this one, I would like us to visit our worksheet so that we can solve that question from there. So let's visit the worksheet. So this is our question 2, and the A is what? At most 3 cells, right? So at most 3 calls, right? So it will be probability that our x is less than or equal to 3, which is equal to probability that x is equal to 0 plus probability that x is equal to 1 plus probability that x is equal to 2 plus probability that x is equal to 3, right? So we just have our PMF of this one, right? So here we are just going to substitute the lambda and the x. So first you are going to pick that s is equal to 0, and you do that. You are going to pick that s is equal to 1, and you do that. You are going to pick that s is equal to 2, and you do that. You are going to pick that s is equal to 3, and you do that, right? So at the end of the day here, here will be e raised to the power negative 3. The negative 3 is what? The lambda, right? That's for what? The lambda, right? As you can see here, e raised to the power negative lambda, right? So e raised to the power negative 3 times what? Lambda, which is 3 raised to the power 0. That's for our x. Our x here is 0 divided by our x. That's what? 0 factorial plus e raised to the power negative 3, right? Times 3 raised to the power 1. So you see that 3 here is the lambda, and our x is 1 over 1 factorial plus e raised to the power negative 3 times 3 raised to the power 2 divided by 2 factorial, right? Plus e raised to the power negative 3 times 3 raised to the power 3 divided by our 3 factorial for when our x is 3 and where our x is 2. So this is what you get, right? This is what you get. So once you point this one in the calculator, you're going to get 0.0498. Point this on the calculator, you're going to get 0.1494. Point this on the calculator, you're going to get this. You point this on the calculator, you are going to get what? That, right? So once you add everything, you are going to get 0.6472 to be what? Your final answer. And then we have at least what? 3 cores, right? So it will be probably that our x is greater or equal to 3, which is equal to 1 minus probably that our x is less than or equal to what? 2, right? So here we are going to have 1 minus probably that our x is equal to 0 plus probably that our x is equal to 1 plus our probability that our x is equal to what? 2, right? So we are going to add all of this and then subtract it from 1. So here we e raised to the power negative 3 times 3 raised to the power 0 divided by 0. Since our x was 0, that's the reason I see here to be 0, here to be 0. And then the same thing we are going to repeat, just by we are going to change where the x is. So here is 1, so here will be 1, here will be 1, and here is 2, so here will be 2 and then 2. Right, so once you put everything on the calculator, you are going to get 1 minus 0.4292. Right, you point this, you add, you get 0.4232, right, and then subtract it from 1, you are going to get 0.57618, right? Yes, that's our probability that our x is greater than or equal to what? 3. And then we have 5 or more, right? 5 or more. So here probability that our x is greater than or equal to 5, right? We will be having 1 minus probability that our x is less than what? 5, right? 1 minus probability that our x is less than 5. That's correct. Or 1 minus probability that our x is less than or equal to what? 4, right? So here I'm going to start from probability that our x is equal to 0. 1 minus probability that our x is equal to 0 plus probability that x is equal to 1. Probability that x is equal to 2 plus x is equal to 3 plus x is equal to what? 4. I'm going to do that individually, right? So 1 minus that. So you see the place where it will be changing is what? Where we have the x's, right? So here x is 0, that's the reason why I see 0 0 here. X is 1, that's the reason why I see 1 1 here. X is 2, that's the reason why I see 2 2 here. X is 3, that's the reason why I see 3 3 here. X is 4, that's the reason why you are seeing the 4 4 here, right? So once you point everything on the calculator, that is how you are going to get, and then subtract it from 1, you get our final answer to be 0.1848. So this is the end for our Poisson distribution class. So in case if we are asked to find the variance for this distribution, the variance for this question will surely give us what? 3, right? Since let's say if we are asked to find the variance of the distribution, right? So our var of x will be equal to what? Lambda, right? So here we got our lambda to be what? 3, right? So at the end of the day, this is how we can find our variance. And the story we can be asked to find our standard deviation, our SD, s dot d of what? X, which will surely give us square root of what? Our variance, right? So here in this sense, give us square root of what? 3. So thank you for watching. This is Statistics and Mathematics Twitter channel. If you haven't subscribed, kindly subscribe so that once we upload any video on statistical method, you guys will receive it. Thank you. Bye. Have a great day.